Here is the problem that we are going to solve today. Two planes simultaneously take off from the same airport. Plane A flies 400 miles per hour at north 20 east. Plane B flies 500 miles per hour at south 30 east. How far apart are the planes after 3 hours? What are the bearings from plane A to plane B at the end of the 3 hours? We'll start by drawing our compass rose. Since the plane is at a bearing of north 20 east, we put the line in the first quadrant and make a 20-degree angle outside of the line. Then we label the line 1200 miles per hour because we are going 400 miles per hour for 3 hours. Now we put our south 30 west line in the fourth quadrant, making the 30-degree angle on the outside and labeling it 1500 mph because the plane is going 500 miles per hour for 30 hours as well. Finally, we connect the two lines to create the bearing we're looking for and add the angles 60 degrees and 70 degrees because 90 minus 30 is 60 and 90 minus 20 is 70. Looking at the triangle, we have SAS, which means use law of cosines. I labeled each side, but A and B are actually switched. I fix it later on in the video. The equation for law of cosines is a squared equals b squared plus c squared minus 2ac times cosine of a. Now we fill in the values for the equation, so we have a squared equals 1200 squared plus 1500 squared minus 2 times 1200 times 1500 times cosine of 130. Here it does not matter that I switch the values of a and b because it will give us the same answer. Now after doing out the equation, you get that a squared equals 6,004,035.395. Now you square both sides of the equation and you come to the conclusion that a is equal to 2,450.31. Since the other side lengths of the triangle are using miles per hour as units, we can also use miles per hour for our units for this measure. Here you can see that I have adjusted the variables so they are now correct, and I label A as 2,450.31 miles per hour. This blue line is the bearing that we are trying to find for our solution. Since we're looking for the bearing of this line, we label that top corner of the triangle theta. We still have SAS as well as SSS now, so we still use law of cosines, but we use the inverse law of cosines. The equation that we use for inverse cosine is inverse cosine times a squared plus b squared minus c squared over 2ab is equal to angle C. Now we fill in the variables, so we have inverse cosine times 1200 squared plus 2450.31 squared minus 1500 squared over 2 times 1200 times 2450.31. After doing out the math, you get that angle C is equal to 27.97 degrees, which is theta. Now we need to use our alternate interior angles to find the exact bearing. We draw an imaginary line that makes a 90-degree angle to mimic the compass rose that the bearing should come off of. Here I flip my paper so that you can see the alternate interior angles better because they are where the horizontal parallel lines are, including our imaginary line. Our imaginary line creates a smaller triangle which has the angles of 70, 90, and then 20 degrees, which lies within the 27.97 degree angle. To find the measure of our bearing, we need to subtract the smaller triangle measure from the larger triangle measure, so we have 27.97 minus 20, and we get 7.97. Here you can see by my arrow that the line is going in a slightly southeast direction. Therefore, our final bearing is south 7.97 degrees east.